I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. In this topic, we will discuss about the internal blocks present in cathode ray oscilloscope. Already we have discussed about vertical amplifier and continuous sweep signal generator. So in the continuous sweep signal generator, it generates the sweep signal continuously irrespective of input. So if you are using the continuous sweep signal generator, we can generate the signals continuously. But that is helpful whenever the input signal having a constant amplitude and constant frequency. But sometimes the input signal may be a voice signal, or sometimes the input signal is some music signal. If the input signal is either voice or a music signal, the amplitude levels are continuously changing from high to low and low to high. At the same time, sometimes the frequency levels also changes. In this case, it is not applicable to use a continuous sweep signal generator. So that we are using this triggered sweep CRO. In this triggered sweep CRO, we are applying the triggering input. According to the triggering input, the sweep signal generates the sweep signal generator generates the sweep signal. And coming to the circuit diagram of the triggered sweep CRO, it consists of resistance RT, CT, resistances R3, R4 and UJT. Along with this, we have a triggered circuit or triggered input. Based upon the triggering input only, the sweep circuit generates the output. Along with this, the main important parameter that is present in the triggered sweep CRO is the diode. If the diode is in the on state, then only it produces the output. If the diode is in the off state, no output will be generated in the output section. Coming to the operation, initially UJT is present in off state. As the UJT is present in the off state, based upon the supply voltage, the capacitor starts charging through the resistance R. Whenever the capacitor starts charging, if it reaches to the maximum value, then the emitter voltage is greater than that of base voltage, then UJT is turned into on state. As the UJT is turned into on state, the capacitor starts discharging, and then if the capacitor discharges to a minimum value, again UJT is present into off state. If the UJT is present in the off state, again from the supply voltage, it is turned into on state. But in this operation, the diode plays a major role. The capacitor charges to a maximum value, or whenever it reaches to the maximum value, based upon the cut-in voltage of the diode, even though there is a supply voltage, capacitor stops charging, and if the input is maintained as constant during the time interval, the capacitor also maintain constant charging. So if you observe the output waveform, this is the triggering signal. We are applying the negative triggering pulse. If the triggering pulse we are applying initially, if we are applying the triggering pulse, observe from this circuit. Whenever we apply the triggering pulse, according to that, if you apply the triggering input, according to that, the UJT is turned into on state. When UJT is turned into on state, at the same time, based upon the supply voltage, capacitor starts charging. As the capacitor, irrespective of UJT condition, the capacitor charges continuously and it reaches to a value which is equal to the cut-in voltage of the diode. At that point, even though input voltage is maintained as constant, the capacitor stops charging, and from here till the input voltage is low, the capacitor maintains constant output. Whenever the input signal lowers from maximum value to the minimum value. Then UJT is turned into on state. The capacitor starts discharging. As we are applying the negative triggering pulse, if you apply the negative triggering pulse, then UJT is turned into on state. The capacitor starts discharges and it reaches to a minimum value. Again, whenever capacitor reaches to a minimum value, UJT is turned into off state, and at the same time we are applying the triggering pulse. According to the triggering pulse, the capacitor starts charging through the supply voltage and it reaches to the maximum value till it reaches the cut-in voltage of the diode. Whenever the diode reaches the cut-in voltage, it maintains constant output amplitude. This is the triggered sweep circuit. In this triggered sweep circuit, the output voltage is maintained as constant when the diode has the cut-in voltage. So if you observe this triggered sweep circuit, based upon the cut-in voltage of the diode, the output voltage is maintained as constant. Similar to the normal sweep circuit, the triggered sweep CRO also produces the output voltage that depends upon charging and discharging intervals of capacitor. But the output is maintained as constant till whenever the output voltage reaches the cut-in voltage of the diode. In this, we have three intervals. Previously, in continuous sweep, we have only charging and discharging. That's why we have only trace and retrace periods. But in triggered sweep circuit, sometime during certain time interval, the output across the capacitor maintain constant. That is, period is called as holding period or hold period. And this is sweep period, and this is called as retrace period. When the capacitor starts charging and it reaches to the maximum value, this interval is called as a sweep time interval or sweep period, where whenever the capacitor reaches to the maximum value, which is equal to the cut-in voltage of the diode, even after if you apply the input voltage, the output is maintained as constant till the input voltage changes from one value to the another value. That interval is called as hold period. Whereas when the triggering pulse changes its level, the capacitor starts discharging. That period is called as retrace period. So we have trace period or sweep period. So we have sweep period, retrace period and hold period. This triggered sweep circuit is mainly applicable whenever the input is given in the form of a voice signal or in the form of a music signal, because it is not the continuous one, it is the triggered sweep circuit. Whenever we apply the triggering pulse, according to that, based upon the supply voltage, the capacitor starts charging. Whenever it reaches to the maximum value, based upon that and based upon the cut-in voltage of the diode, UJT is turned into on state. When UJT is turned into on state, the capacitor starts discharging. The process of triggered sweep circuit is similar to that of continuous sweep only. But in triggered sweep circuit, along with the supply voltage, we have given triggering input. At the same time, a diode is present in the triggered sweep circuit to maintain the output voltage to one particular level. Next one is triggered pulse circuit. How we are providing the triggering signal, or how can we generate the triggered signal? If you observe the cathode ray oscilloscope, the main important parameters are vertical amplifier, triggered circuit and time-based generator and horizontal amplifier. Already we have discussed about vertical amplifier and triggered circuit. We have discussed about vertical amplifier and time-based generator. In that time-based generator, we have continuous sweep signal time-based generator and a triggered time-based generator. And now it is triggered pulse circuit. How can we provide the triggering signal? So to generate the triggering signal, we have three different ways. One is internally we can generate the signal, or external with the help of a trigger level, we can generate the triggering pulse. If you observe the triggering pulse circuit, The triggering pulse circuit, the input for the triggering pulse circuit is the output coming from the vertical amplifier. When we apply the output coming from the vertical amplifier to a comparator circuit, the comparator, as we know that the comparator always consists of two inputs. It always compares the given two input signal and according to that it produces the output. In this case also we have one comparator. That comparator consists of two inputs. One is the input coming from the vertical amplifier and another one is the trigger level. Whether it be a positive trigger level or a negative triggering level. If you apply a positive triggering level to the comparator circuit, it compares the positive triggering level with your input signal coming from the vertical amplifier. If both inputs are same, then signal is sent to the pulse generator. In the case of with the help of pulse generator, it generates the pulse signal. Similarly, if the input signal is a vertical amplifier, one of the input, and another input is the negative trigger level, we are applying the negative trigger level to a comparator. In this case also the comparator will compare two input signals. If both the inputs are same, then the output is given to pulse generator that both the inputs are same. Then pulse generator generates the signal and finally it produces the triggering output. We have three different ways. With the help of internal signal, we can generate the vertical amplifier input, or externally we can apply the vertical signal as the input, or with the help of vertical amplifier directly we can apply the input. These are the three different ways we can apply the input to the comparator. And we can also apply the input with the help of transformer. Finally, if you apply input from any manner, that is internally from the vertical amplifier or from external section or with the help of transformer also, always the comparator will compare the two inputs. One is coming from vertical section and another one is the triggering level. Always comparator compare the trigger level with the three different ways of input. If both the levels are same, then comparator gives the signal to the pulse generator to generate the pulses. This is how triggering pulse will be generated. Next, delay line. The another important parameter present in cathode ray oscilloscope is the delay line. Why we need delay line? What is the advantage of delay line in triggered sweep circuits? If you observe the output of CRT, if delay line is not present, then some part of input signal will be missed. Only the signal after this dashed line will be observed in the output section. Some part of the input signal will be missed because there exists no delay between vertical amplifier section and horizontal amplifier section. Due to this, when the delay line is not present in the CRO vertical and horizontal amplifier section, some sort of input signal will be lost. Due to this, there may be a loss in getting the output signal. That's why we are using delay line in vertical amplifier section. So, why we need delay line means we are applying the amplified signal coming from the main amplifier to the vertical deflection plates. But at the same time, the horizontal amplifier requires the output coming from the vertical amplifier. So after amplification only, the vertical amplifier will give the signal to sweep generator. According to that, it generates the signal and then give to the horizontal amplifier section. So it requires certain time for horizontal amplifiers to amplify the input signal. During this time interval, the vertical amplifier is given to delay line. So whenever we apply the input signal to the delay line with a delay of 200 nanoseconds, within this time duration, the output coming from the main amplifier is given to the triggering circuit. From the triggering circuit, we are applying that to sweep generator. Then the sweep signal will be generated and then the sweep signal is applied to a horizontal amplifier. In this horizontal amplifier section, with the help of input signal, the horizontal amplifier will take the sweep signal and then that is given to horizontal deflection plates. So the sweep signal generator requires a time delay of 80 nanoseconds and the vertical amplifier has the delay of 200 nanoseconds. During this time interval, finally, both horizontal amplifier section and vertical amplifier sections will give the input to vertical and horizontal deflection plates at a time, and finally it produces the output waveform without any signal loss. If the delay line is not present in the triggered sweep, if the delay line is not present in the vertical amplifier section, means after amplification, the output coming from the vertical amplifier is given to vertical deflection plates. Then the output coming from vertical amplifier is given to horizontal amplifier. After completion of amplification, the horizontal amplifiers will give the inputs to horizontal deflection plates. During this time, the vertical amplifier which is given the input to the vertical deflection plates, that information will be lost, and the horizontal amplifier input, the horizontal deflection plates inputs and vertical plates input both will be mismatched, and finally we are getting a very blurred, or the output, we are getting an image which does not consist of vertical or horizontal information continuously. There is a mismatch between vertical section and horizontal section. To avoid the mismatch between vertical and horizontal section, till the completion of horizontal amplification, vertical amplifier has to wait. That's why we are providing the delay of 200 nanoseconds. So that even though vertical amplifier completes the amplification, there exists a delay of 200 nanoseconds. During this time interval, the output coming from vertical amplifier is given to the triggering circuit. From the triggering circuit, we are applying the triggering pulse to the sweep generator. Next, it generates the sweep signal. That sweep signal is given to horizontal amplifier. Then, according to the input signal, the horizontal amplifier will amplify the signal, and finally, both horizontal amplifier and vertical amplifier will give the input to horizontal deflection plates and vertical deflection plates at a time, so that without any mismatch, it produces the output in the output section. That is why we are using delay lines in CRO, vertical amplifier section. This is about delay line in triggered sweep circuits. These are the main blocks present in cathode ray oscilloscopes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.